Now let me present my screen and let me know if it's visible. So is my screen visible? Are we good to go? Okay, fine. Thank you so much. So hello again everybody, how's it going? I am Arjun, a pre-final year computer science student from Sastra University, and today we have Sreesan with us, who is a pre-final year CSBS student. We are going to handle the session Math for Competitive Programming. You might guys have a big question that we have studied M1, M2, and there are even some third year guys who have studied M3. So why do we need to learn this? What is math for competitive programming? We have been studying maths from our kindergarten since we completed 12th, and even in the engineering programs we have studied math. So how is this math different? This is totally based on logic and algorithms to improve your naive solutions to most of the problems. So here we'll be covering concepts from number theory, bit manipulation, how to compute GCD, LCM, and so and so. So now let's get started. Okay, so the first topic that we are going to see is time and space complexity. I've come across many fresher guys who have asked me this question. So, what is time and space complexity? They are confused about the terms like O of n. They have seen quotes of editorials with and gigs for gigs posts with these names O of n. So, this solution is going to be O of n square. So, what does this mean? That is what we will be seeing today. So the big O notation, which is the famous notation used for time complexity, is also known as Landau's symbol. So this is going to be put in simple words. This is going to mean something like order of. So what is this? So now let's take a simple example and try to understand this. So I am giving you an array of integers. So all integers are going to be positive and the size is mentioned as n. And now I am asking you to find the maximum integer out of these. So how will you do? You will start iterating a for loop which will start from I equals 0 and it will obviously go I less than n and you will increment I in each step and you will be having a temporary variable which is going to store the max and in each step you will be comparing the temporary variable with the current element. Okay, so temp equals maximum of temp and AR of I. So this is what you will be doing. So how many steps you will take? You will be doing n iterations for this. So if I'm going to give you an array of 10 numbers, you will take 10 iterations. If it is going to be of 1000 numbers, you will be taking 1000 iterations to solve this problem. So the number of steps you are taking to solve this question depends directly upon n. So in this case, we will be saying that this is called O of n time complexity. That is, the order algorithm depends directly on the size of input linearly. So we say O of n. What if I have told you prior that the given list is going to be in sorted order? For example, I'm going to give you numbers like 1, 2, 3, 4, 5. And I've already told you that the given array is going to be in sorted order. So in a single step, you will directly say that the last number is going to be the maximum element. So this will take constant time. It does not depend on the size of the array. Even if it is going to be 10 elements, you will say in a single step that the last element is max. Doesn't matter if it is going to be 1000 elements. You can say that the last element is obviously going to be the maximum element. So here if you see, you're taking constant time which does not depend upon the input. So in this case, we will say that it is going to be O of 1. So now let's take a deeper look into what this means. So the standard definition of time complexity, that is the big O notation, there are other notations like theta, omega, but in competitive programming, the most famous one is going to be the big O notation. Most people say it as big O, OH. So what the big O notation means is it is going to specify the upper bound for something. So now let's take an example. If there is going to be an algorithm whose the number of iterations is a function of n. It can be anything. It can be something like 2n square. It can be something like y equals n or log n, anything. It is going to be a function of n. In that case, if there is a function g of n such that when multiplied with some constant c for all large values of n, we see that the g of n should be greater than f of n. So for here, you will be able to see that there is something called n naught. The x-axis is the size of the input, and y-axis says the how the function grows with respect to n. So there is something n naught, and towards the left of n naught, you will be able to see that the graph is inconsistent. At some places, you will see f of n is smaller than c into g of n, and in some places, you will see f of n is greater than g of n. But what we are concentrated upon is, so if you are going to have 10 elements, it doesn't matter if you say in a single step or you're going to iterate over the whole array. Nowadays computers are running in gigahertz, so it doesn't matter if you're directly saying or iterating to an array of size 10 and then saying the answer. It doesn't matter. The problem arises when the number of elements are something like 10 power 8, 10 power 18. At these places you will be able to face a lag in your algorithm. That is where time complexity becomes important. So, for example, if our algorithm, some algorithm, let's say the algorithm we have taken is taking n iterations. For example, if we are, I'm going to say that you will be given an array of size n. You must iterate through it 2 times and print all the numbers. So the number of iterations will be 2n. So now let us take f of n equals 2n. So we must be able to find the smallest g of n such that when multiplied by some constant, it is always greater than 2 into n. So we can simply take it as 3n or 5n, anything. So here c is going to be 5 and then g of n is going to be just equal to n. So we say our algorithm runs in O of n time complexity. So there are famous time complexity notations. As we see big O notation, I have listed all famous ones. So O of 1 is going to take constant time. That means that your algorithm does not depend on the input size. Next comes O of log n. This will take logarithmic time. And then O of n, which is going to be linear. O of n log n, which is called as linear rhythmic. O of n square is known as quadratic. O of n cube, obviously it is known as cubic. Then comes O of 2 power n. It is something like O of some constant power n. This is exponential. These cases will arrive when there is, excuse me guys, I will be back in a minute.
Sorry for the interruption. If you have any doubts, you can put it in the chat menu. We'll take it and then we'll cover it in the end of the session if it takes much more time than expected.
Yeah, I am back. So let's continue. So these time complexities arrive when you are asked some question like given an array, find all subsets of it. So it will obviously take 2 power n time complexity. So you take 2 power n iterations. For each number, there are going to be two possibilities. Either that number can be in the answer or it cannot be. So these type of time complexity should be avoided. And the last famous one is going to be O of n factorial, which is known as factorial time complexity. So always it is better to have O of 1, that is constant time. If your algorithm doesn't depend on the input size, it will be the best algorithm obviously. Otherwise, some good algorithms can be of time complexities O of n log n, O of n, and even n log n. But you should always try to refrain from these kind of algorithms which run in O of n square 2 power n or O of n factorial. That is why these are all marked in red and we are given green and yellow color for these. So now let's take another example. You might have a doubt. As we have covered sorting in last session, most of the sorting algorithms, even if you take STL sort, it will be running in a worst case time complexity of n into log n. Whenever you approach some problem, if it takes sorting, obviously that sorting part will take n into log n time complexity. So now you have a question in which you need to sort the array first, and then you are going to run a quadratic loop, so a nested for loop which goes from I equals 0 to n. Again this goes from I equals 0 to n. So what will be the time complexity of this? How do we analyze this in context? Because you cannot always take a graph, draw the graph, find some g of n and then analyze. Whenever you design an algorithm, you should be able to guess the algorithm. That is what we did in computative programming. There are theorems for these, like Master's theorem, etc., which you will be studying in your fourth semesters in the subject called Design and Analysis of Algorithms. But that is not required in comparative programming. You should be just able to guess what will be the average time complexity for the same. So as we have discussed, sorting will take O of n log n, and this will run for n times, and this is going to run for again n times. So when combined, this will give O of n square. So if this is going to be my algorithm, which do I take as the overall time complexity of this? So yes, the overall time complexity will be n into log n plus n square. So here if you see, the maximum order of n is going to be n square, because log n is very smaller than n. So this is going to be approximately equal to linear time. And then you have this n square, which is the greatest power of n. So our overall time complexity can be stated as O of n square. This is how you analyze algorithms. So this is the same way you are going to analyze space. So if an array is given, you are going to take some extra few arrays, then the space complexity will increase with respect to the array size. And if you are going to just have the given array and solve the question, well and good, it is going to take O of 1 space complexity. What is the most important part in competitive programming is time complexity when compared to space complexity. So how do you solve questions based on this? How is this going to help in competitive programming? In most questions in CodeChef or CodeForce or any contest competitive programming platform you take, you will see a section called constraints, where you will be stated that the number of test cases is going to be less than or equal to 1000. So the input size, that is the array size, is going to be less than 10 power 5. So how is this going to help you in solving questions? So by looking at this, what you can do is, the the common factor for all online judges is that most of the online judges will be able to perform 10 power 8 operations per second. So if you're going to see the number of test cases is 1000, the number of input size is going to be up to 10 power 5. When you multiply these, so for all test cases combined, the input size is going to be 10 power 5 into 1000, which is going to be 10 power 8. So by looking at this, you can see that, okay, the input size is going to be approximately 10 power 8, so that I should be able to solve this in O of n. And if the input size is going to be something like 10 power 18, 10 power 64, in those cases, you can go with log n approach or O of 1 approach. And in most cases, if the input size is going to be 10 power 5, then the most expected time complexity will be n log n. And if it is n log n, in around 60% of the cases, the question will depend upon sorting. If it is going to be based on log n, then it is going to be dependent upon binary search. By this, you can approximately guess how should I approach this problem. First, you try brute force, analyze the time complexity as we have discussed earlier, then try to optimize your solution. Look at the constraints, then decide which approach would help you the most. So I hope you got a gist of what is time complexity and space complexity. In the resources sheet that we are going to provide tomorrow after the part 2 session of CP for competitive programming, in that we have mentioned links for you to learn more upon time complexity and space complexity if you are interested. For competitive programming, I guess this is enough. So are there any doubts based on this, or shall I move to the next part? Guys, can somebody respond? Is it okay? Okay, fine. Thank you so much for responding. Now let's move to the next part, which is a very important concept, that is, okay, before we go to prime sieve, let us discuss what GCD algorithm is. So in most questions, you would have seen that you need to find the GCD, which is going to be the greatest common divisors between two numbers. So let me write it. GCD is known as, sorry, is the greatest common divisor. You can also call it as HCF, which most of us are used to, but in computer programming, most forums or most questions mention it as GCD. So how do we find the greatest common divisor of two numbers? For example, if you are given two numbers like 15 and 45, the greatest common divisor of these would be 15, because 15 divides itself obviously, and 15 is a factor of 45. So in this case, you must be able to find that the greatest common divisor of 15 and 45 is going to be 15. So now let us discuss the brute force approach of how to find GCD. We are going to follow a naive approach. What is it? If you are given two integers a and b, obviously the greatest common divisor of these would be lesser than minimum of a comma b. You agree with me? There is no
Yes,
other
yes.
go. There is no other go. You should all agree with me. That is the only possible case for you. Because if you are going to have any number, you cannot have a GCD which is greater than one number. So yeah. So what do we do? So we run a for loop from I equals 2, because 1 is obviously factor for every number. So we run a for loop from I equals 2 and I less than minimum of a. We find the minimum. Let us assume that a is going to be the minimum. So we run a for loop from I equals I less than or equal to a and I plus plus. And in each case, if we check that if the remainder when a divided by I is going to be equal to 0 or not. Am I doing something wrong? One second, guys, let me check. So we are going to find the greatest common divisor. Yeah, okay. In each case, what are we going to do? Whenever a is I is a factor of a and I is also a factor of b, we get this condition to be true. So a mod I equals 0 and b mod I equal to 0. In that case, our GCD would be I, and then we will be breaking this for loop. So as we know time complexity, now let's analyze. So this is going from 2 to a. So we will be doing approximately a minus 1 iterations. So this is obviously going to be O of a, and we can also call it as O of n because it depends on the input size. So is this going to be the most optimal approach to find GCD? No. The great mathematician Euclid has come up with an algorithm which says GCD of a comma b is the same as GCD of b mod a and a. What is this? Let us assume the smaller number is a and the bigger number is b. Whenever we have two numbers a and b such that a is less than b, the GCD of a comma b would be such that is the same as GCD of b mod a and a. And he has also given us another condition that GCD of a comma 0 would be a. So I hope you get this. What if a is not less
Can you
than?
give us an example for this?
Yeah, sure. Now let's do a dry run on this algorithm. So let us take the case. Let us take two prime numbers, for example. Let me take 7 and 13. So in this case, GCD of 7 comma 13 would be the same as GCD of 13 mod 7 comma 7. So what is 13 mod 7? We will have it as GCD of 6 comma 7. So now our A turns to be 6 and now our B is going to be 7. Now we will again apply the same algorithm. So 7 mod 6 is going to give us 1 and we will have 6 over here. The next step again 6 mod 1 is going to give us 0, and then we will have 1 over here. So we see that one of the inputs have turned out to be 0. In that case, we will be printing the other one. So GCD of 7 comma 13 would be 1. Now let us take another example too for you to understand better. What is GCD of 6 comma 24? In this case, if you see, in the first step itself, we will get one operand to be 0. So we have 24 mod 6 and 6 in the right side. So this will be GCD of 0 comma 6. So we see that the greatest common divisor of 6 comma 24 will be 6. So hope you are getting it right. Guys, are you getting it, or let us try run this algorithm on another input?
Yeah, I think they can understand. So I think we can move to the next.
Yeah, okay, fine.
Yeah.
So
Anu,
how do we implement this algorithm? It is simple.
Wait. Did someone ask anything?
is there any specific proof for this Euclid algorithms working, or should we take the word for it?
Sorry, can you please come again? I can't get your question.
Is there any specific mathematical or algorithmic proof for Euclid's algorithm?
Yeah, as the session is just going to be around 1.5 hours, I have a lot of concepts to cover. That's why I am not going with proofs. Otherwise, we can take proofs and discussed. If you are really interested about GCD algorithm and its proof, we have provided the link in the CP, the resource we are going to provide you tomorrow. Tomorrow we will be handling you a PDF which contains the lecture notes as well as the links for you to study in deep each concept. So in that, if you're really interested, you can go have a look at the proofs.
Thanks a lot, Anna.
Yeah, okay. Let's continue. So how do we implement this? So in the first place, let us declare a function which is going to be GCD of int a comma b. I'm just writing the pseudocode. If b equals 0, in that case, we would be returning a. Sorry. If a equals 0, in that case, we would be returning b. Otherwise, we call GCD of b mod a comma a. So this is a recursive function, and this is the base case for the same. When a is going to be 0, we will be returning b. Otherwise, we will be recursively calling b mod a comma a. So you might have another doubt. I have said that let us assume a to be lesser than or equal to b. What if a is greater than b? How will our function going? How is our function going to work? So this function is capable of swapping the operations. Now let us take a case. If we are going to pass 13 comma 7, what will happen in that case? So here 13 is going to be a and 7 is going to be b. So that our algorithm in the next step would do GCD of 7 mod 13, and then a will come over here. So it is 13. So in this case, if you see, this will give us GCD of 7 comma 13. We have given as 13 comma 7, but in the first step our algorithm has swapped the numbers such that a is less than or equal to b. Then it will proceed calling the next recursive call. So what is the time complexity of this? You would be able to see that at most this solution will take less than the shorter number. For example, if a is going to be the minimum of a comma b, that the number of steps taken to calculate the GCD of a comma b would obviously be less than or equal to a. Time complexity of this is O of log of minimum of a comma b. So if you're going to assume a is always lesser than b, you can directly say the time complexity is O of log a. There is a mathematical induction proof for the same, to which the link is given in the CP resource sheet. So if you're really interested, you can go have a look at the same. So what you need with respect to CP, you need not know proofs. You just need to understand these algorithms and its time complexity and be able to implement wherever required. And the other skill you need is that you should be able to analyze the algorithms you write based on guessing or analyzing at each step how many iterations is going to be taken with respect to the input size. So yeah, so the next concept we are going to see is LCM. This is a very simple concept, but yet it is very useful one in competitive programming contests. So we all have studied LCM from our kindergarten stages. So what is LCM? It is going to be the least common factor, sorry, the least common multiple of two numbers A and B. So how do we find this? So for example, if A is going to have factors like, let me call the factors of A as A, B and C, and B is going to have factors as C and D. So what will be the greatest least common multiple of A and B? It is simple. Most of you would have simply answered this. It is going to be, we are going to eliminate the common factor, and then it would obviously be A into B into D. So I hope you get it. For example, if the least common multiple of 6 and 12 is asked, the factors of 6 are going to be obviously 1, 2, 3, and 6. And for 12, we will have the factors as 1, 2, 4. So here we'll have 3 and 6 and finally 12. We will be eliminating the common factors. So it is going to be 1, 2, 3, and 6. Sorry, I think I'm doing a mistake over here. We should be getting 12 as our answer.
Four and six you don't have to do. It's a fine.
Yeah, okay. I have just mistaken the concept. Okay, sorry guys. So it is not going to be this way how we will be calculating the LCM. So let me come, my sincere apologies for the same. So if you are going to find the LCM of two integers A and B, so we are focused in finding some multiple of this. So obviously we know that A into B is going to be a multiple of A and B. But we are focused in finding the least common multiple for the same. So how do we find it? So we will have factors of A and factors of B, and we will be finding the greatest common factor of both, and we will be dividing this by A and B by the greatest common divisor, that is the greatest common factor or highest common factor of A comma B. So if you take 6 and 12 now, I think the algorithm will work perfectly. So it is going to be 1, 2, 3, and 6. And for 12, we will have 1, 2, 3, 4, and 12. So what is 6 multiplied by 12? It is going to be 72. And what we will do is we will be dividing 72 by the greatest common divisor of 6 and 12, that is GCD of 6 and 12. So this will return us 6, and when 72 is divided by 6, we will get the answer to be 12. So we can confidently say that this is going to be the least common multiple of 6 and 12. So I hope you're able to write the function for the same way we wrote for GCD. What we will have to do is first predefine the GCD function, and then we will be calling the LCM function, which is going to take two integers A and B. And then what we'll do is we'll first multiply A and B, and then we will divide it by GCD of A comma B. So we are calling the GCD function over here, and we will be returning this value as our answer. So I hope you get the same. Yes. So can I consider the silence as
So we
you
should
understood?
have another function GCD and then call it inside this function, right?
Yeah, exactly.
Okay, yeah, good.
So I'm good to go, right, to the next concept.
Yes.
Bharani C has asked a question.
Yeah, okay. In GCD, may I know the max how? It should be min, right? Max in the sense I'm not getting your question.
I guess referring to the previous answer, the log of max of a comma b prime.
Yeah, yes. In Sundar mentioned log of max a comma b. It should be min of a comma b, right?
Yeah, it is going to be minimum of a comma b. There are
Yeah.
proofs for the same too, which for the link to the link also we have provided in the CP resource sheet. You can refer to the same. The
Okay.
link, the proof is based on some mathematical induction. So if I start explaining the same, it will take a lot of time. That's why I avoided the same.
Okay.
There are some websites like Code Forces which have mentioned it as log of max of a comma b. Yeah, Sundar's point is obviously right because he might have referred sites like Code Forces where they have mentioned it as log of max of a comma b. But I have seen a lot of proofs and I am satisfied by the time complexity that it is log of min of a comma b. So if there is some contradictory proof to prove it as log of a comma, it is going to be max of a comma b. So we all can learn. So we can remember it by formula that for any two numbers a comma b, a into b equals gcd of a comma b into LCM of a. Yeah, you are right, Achutan. That's wonderful. To calculate this GCD, you will have to call that function GCD, which is you will also have a GCD algorithm, which I hope Sreesan had discussed in the STL course, which is going to be known as underscore underscore GCD. This takes two parameters and returns the GCD of the same. But I have seen some forums stating that there is some problem with this GCD algorithm, so I always prefer writing my own GCD function whenever I attend contests. So now is it clear?
Clear it.
Yeah, okay. I think we can move to the next concept, which is going to be a very interesting one. Okay, it is over here. The next concept we are going to see is the prime sieve. So most of you would have heard the word sieve of Eratosthenes. Have anybody heard this term? Is there somebody who has already heard of this term sieve of Eratosthenes? Yeah, so it might be like a frightening term, but it is really not. Eratosthenes was a great mathematician who has given this sieve. So what does this word sieve means? It is just like filtering. So a sieve is obviously used to filter floor. We might have seen in our houses. So this sieve is to filter prime numbers from the other numbers. So what is the problem over here? You need to find if some given number n is prime or not. So otherwise it is going to be a composite number. So if it is going to be one number, so it is going to be a single number. You guys might ask a question. So what is the problem in this? I will run a for loop from I equals 0 and it will go up to I less than n, and I will see if any of these I is able to divide n, that is n mod I is equal to 0. In that case, it is definitely going to be a co-prime number. If no I less than n is able to divide n without any remainder, then obviously n is going to be a prime number. This is an obvious intuition or a naive approach that will come into your mind whenever you get to know about this question. But what is the problem over here? For a single number, the time complexity would be O of n. So if I'm saying that I'm going to query based on 1000 test cases and each number would be something like 10 power 5, it can be a max of 10 power 5. So how will you be able to run a O of n algorithm? So this n over here just depends on this 10 power 5. This is going to be t. So if I take the algorithm, it will the actual algorithm for the whole problem would be O of t into n. And this is definitely not going to run in 1 second for most of the questions. And you will get a big bold text called TLE, time limit exceeded. And you will be thinking of how to optimize my solution. The first possible optimization that we can do is just observe the factors of numbers. For example, if I'm going to take 24, what are the factors of 24? it is going to be 1, 24, 2, 12, 3, 8, 4, and 6. So I hope there are no more factors of 24. So we have 8 factors in total. And we see that all of these factors occur in pairs. Even if 20, for example, if we take 25, we have 1, 5, and 25. Even this is going to be a pair because we will get 25 only when 5 is multiplied by 5. So factors are always going to be in pairs. So what is the observation we can make from this? For any number, the factors are going to be in pairs such that one factor will lie towards the left of square root of the number and the other factor would lie to the right of square root of number. If not, both will lie on the square root of this number. So this might be a little bit confusing. Now let's take another case and see. So if I'm going to take the number 64, what are the factors? 1, 64, 2, 32. So 3 is not, so yeah, 3 will not be a factor. So the next factor would be 4, 16. So the next one would be 8 into 8. So I hope these are the factors of 64. So if you see, the first factor is 1 and 64. The next pair would be 2 and 32, 4 and 16, and 8 and 8. So all factors are in pairs such that one of the factors rise towards the left of 8 and the other one lies towards the right of 8. And if that is not possible, both the factors would lie exactly on the square root, that is 8 comma 8. So 8 into 8 will be 64, as you know. So what is the we have made an observation, and how do we make use of this observation? Simple. Instead of just traversing from for I equals 0 to I less than or equal to n, what you can do is you can stop the iteration by I less than or equal to square root of n. So we have decreased the time complexity from O of n to O of square root of n. This is obviously a very good optimization to any algorithm you can make. So if any number less than or equal to square root of n is going to divide the given number without any remainder, then obviously we will know that the given number is going to be a co-prime number. Sorry, it is going to be a composite number. Otherwise, it is going to be a prime number. This is the first possible optimization we can make. But this would be good for a single test case. But as we discussed earlier, what are we going to have a lot of test cases and there are going to be multiple queries. So what will you do in that case? That is the problem over here. That is where the Sieve of Eratosthenes comes very handy. So bear with my handwriting, guys. It is really bad. I understand that. So how does Sieve of Eratosthenes help us? So what we are going to do is we are going to maintain a sieve, that is a big array of size n plus 1. So the first element index will start from 0, 1, 2, and so on up to n. The last index would be n. And what are these going to store? All these are going to store a Boolean value which says if the given number is prime or not. If it is going to be true, that means that the particular index is going to be a prime number. If it is false, it says that it is a composite number. So initially, we assume that all the numbers are prime numbers. So this is a very bad assumption. But yeah, as we proceed, we will able to filter out the prime numbers from the other ones. So what are we going to do here? So we run a for loop which starts from I equals 2. And then we go until the square root of n. So we have already seen why this is. We are going until the square root of n. It is just because if the factors are going to occur in pairs, all the pairs will contain at least one factor such that it lies towards the left of square root. So we need not traverse up to n. We can just stop it over here. And then we increment I. So how is our inner for loop going to be? What our inner for loop is going to do is, it is going to start from I square. So why is it going to start from I square? Just wait for some time and I will explain why this happens. And then we are going to increment j. So what this is doing over here. So how do we make use of this algorithm? How this algorithm works is, first we take some number 2. And then, so let me take a test case where let me take the array size to be around 15. The given number is 15. So we will make an array of size 15 plus 1, that is 16 places. So 0, 1, 2, 3, 4, 5, 6, 7. So yeah, we are done. And then initially everything is going to be true. So we initially assume all of these numbers are going to be prime numbers, except for 0 and 1, because we know that 0 and 1 are not going to be prime, considered as prime numbers. So here we put as false. So yeah, so as we see the algorithm, we are going to start iterating from I equals 2. So we will start the same. We will start iterating from I equals 2. And in the first step, what we are going to do is, we are going to make all multiples of I. If this I is going to be a prime number, we are going to make all multiples of I to be false. It is obvious. We are just making all even numbers to be false. So first 4 will become false, then 6, then we will have 8 to be false, then 10 to be false, 12 will become false, 14 will become false. So this is done. I hope you are understanding this. But as per the given algorithm, we will just start from I square. Yeah, here I square is going to be from 2 and we go up to n. So now let's move on to the next integer. The next prime number is going to be 3. Now we will make all multiples of 3 to be false. So 3 is a prime number. So next 6 will become false. 9 will become false. So it's 9, sorry. And then 12 will become false. We are seeing that 12 is already false because 12 is a factor of 2. 12 is a multiple of 2. And then finally 15 will become false. The next prime number would be 5, then 7, and so on. And we will be doing the same. And after we reach a point, after I is greater than the square root of n, we would be able to confidently say that we have filtered all prime numbers from the composite numbers. And whenever you have a query that if the given number a is going to prime or not, you can just see the prime of a. So this is going to be the index. If prime of a is going to be false, then you can say that a is a composite number. If it is going to be true, you can say that a is a prime number. But the biggest question over here for most of you would be that, why am I starting this from I square? Okay, bro, you said that I is going to run from 2 to less than square root of n. We understood this clearly, as you said that the pairs are going to occur in such way that at least one of those numbers lies towards the left and the other one lies towards the right of square root of n. That is why you are running the for loop only up to square root of n. But why is this j starting from I square? This is because if you are at some index 5, so this is 5, as I already marked, I am taking a new array. So this is the array you already marked for 2, already marked for 3, and now you are at 5. And you are going to mark all multiples of 5 as false. So why do we need to start only at 25, which is going to be 5 square? What about all the multiples of 5 which are going to be here? We will have 10, we will have 15. So why are those not marked? That is because when we mark a multiple of 5, it is going to be 5 multiplied with some number. So initially we will have 5 multiplied by 2, which is going to be 10. Then we will have 5 multiplied by 3, which is going to be 15. We will have 5 multiplied by 4, which is going to be 20. Why are these not marked? Because whenever we mark the multiples of 2, obviously 10 and 20 are covered. Then we mark the multiples of 3, then 15, all multiples of 3 are covered. Then you need not go again from j just greater than I, and you can directly start from j equals I square. I hope you get it. So that the next multiple would obviously be when 5 is multiplied by 5, or else 5 is multiplied by some greater number other than 5. We need not mark the numbers which are the multiples of 5 and 2, 5 and 3, because we have already marked 2 and 3. We are traversing the array from left to right. So that these numbers have been already marked, and when we are 5, we must be marking numbers from 5 square. That is enough. So I hope you are getting it, right? Are there any doubts based on this? So Sujit Kumar has a question. You can just write out the factors of a particular number, and you can notice that they will be repetitive after some point, and that point is the square root of that number.
Oh, that's not a question.
Oh, okay. Oh, he's giving us some information. Okay, fine. Thank you so much, Sujit. So are there any questions over here?
Uh,
Any doubts? Yeah. Someone has started speaking. Please continue.
yeah, so I had this one problem where I have to print all the primes in a given range, like 0 to 100, print all the primes like that. I found
Okay.
this one algorithm like 6n plus 1 or 6n minus 1, but that gives all co-primes also. So how do I find the primes in this?
Yeah, I guess if you check the properties of prime numbers, every prime number that is greater than 2 will be in either one of this case, which is 6n plus 1 or 6n minus 1. So you cannot find all prime numbers within a particular range with this, right? So it is just a property of prime number which says that any prime number can be written in the format 6n plus or minus 1, other than 2, right? So
Yeah,
So there can be also composite numbers which can be written in the form. That's why you are facing the problem.
yeah.
Yeah.
So,
Okay. Fine.
what he's trying to say is every prime number can be written in the format 6n plus or minus 1, but every number that you write in the format of 6n plus or minus 1 is not a prime number. The converse
The
is not true.
converse is not true.
Yeah, so like what particular algorithm can I
Yeah,
use
you
for
can
that
use Sieve
program?
of Eratosthenes as we discussed earlier. So now I will say
Right,
the time complexity of this, and it is going to be one of the best algorithms to find prime sieve.
right, okay.
So how do we analyze the time complexity of this? So at each case, what we are doing is we are taking some number, and then we are finding all the multiples of that number, and we are marking as first. First we start from 2, then 3, then 4, and so on. So we see that the first iteration would be something like n by 2 iterations. Then we will go up to n by 3 and n by 4 and so on, something up to n by k. And if you take n common, you will able to see that it is 1 by 2 plus 1 by 3 plus 1 by, sorry, it is not going to be 1 by 4. It is going to be 1 by 5 over here, because all the denominators are going to be prime numbers, and k is going to be the largest prime number, which is less than square root of n. I hope you get that. And 1 by 5, 1 by 7, and so on. So we have taken n common out. So this is going to be a harmonic progression, to which the proof is given as this would take a time complexity of log n. So there is a proof for this. This is the harmonic progression, which is proved as it takes a time complexity of log n. So in total, our time complexity for this sieve of Eratosthenes is going to be big O of, we have an n over here, so n into log of n. So I hope you get this. It is obviously very better than O of n for each test case that we took, or else it is obviously better than O of n into square root of n, because we discussed that for multiple test cases, so that will be O of square root of t into square root of n, and the first approach that we discussed was t into n. But here we are taking O of n into log n for the pre-computation, that is to find the prime array or the prime sieve, you can call it. And then for each test case, we are just going to find what is the value at that particular index inside the prime array. So that is obviously going to take a constant time complexity. So for the what you call the pre-computation, you will take O of n into log n, and for each test case, the time complexity is going to be O of 1. So the overall time complexity would be O of n into log n plus O of t. So this is the best possible way. There are also algorithms to solve this in O of n, but I am not confident. I am not sure about how those works. I am trying to understand those. You can also have a look at them in the website called CP Algorithms. I have seen an algorithm which takes just O of n time, and I am trying to understand the same. So the most famous one is Sieve of Eratosthenes, which is going to take n into log n, and this is no worse than O of n, because log n is obviously going to be very small number, and when you multiply that with n, it is approximately equal to O of n. So I hope you get this. Now let us move to the next part, that is prime factorization. Now we have understood that how to find prime numbers, whether a given number is prime or not. So the next part is how to find the prime factors of some given number. So once again, let me go show you the code for the same, the side by side, so that you understand it better. So my screen is visible, right? I hope it is visible. So yeah, this is how we find Sieve of Eratosthenes. So I declare a global vector which is known as primes, and I have okay, let us call this function as is prime function. So this is going to generate the sieve of Eratosthenes, which is going to be this prime array. And first what I do is I resize the primes array to be of a size n plus 1, because the indexing is going to start from 0 and the maximum index is going to be n, and so that I resize this to n plus 1 and initialize it to all the values to be true. And obviously prime of 0 and prime of 1 is going to be false, because these two numbers are not considered prime. And as I said, I'm going to run the for loop from 2 up to square root of n. So I have made as I into I is less than or equal to n. That means that I is less than or equal to square root of n. And if that particular number is going to be a prime, then I run a for loop to mark all the multiples of the same to be false. Otherwise, what do I do? Otherwise, I skip and go to the next number and check if it is prime or not. I hope you are getting it. So let us move to the next part, which is prime factorization. So again, now let's discuss the naive approach of this. So how do you prime factorize a number? Any ideas? So if I'm going to give you a number called 24, you must be able to say the prime factors of 24 are only 2. It's only 2, sorry. Sorry, 2 and 3 are the prime factors of 24. There are 2 prime factors for same. How would you say this? Any ideas? Okay, fine. So that's not a problem. Okay, factorize the given number, check for prime. Okay, that's a good idea, but the question is, how are you going to factorize this number? So the naive approach, again, that is the brute force approach, will be like you're going to run a for loop from I equals 0. First, what do you do is check whether the given number is 2 or not. If it is going to be divisible by 2, then you keep on dividing that given number by 2. And then you print the number of 2's in that number. And then what are we going to do? For example, if you are going to have 64, first time when we divide 64 by 2, we will give 32. So the prime factor, one of the prime factors 2. Next, 32 divided by 2 will give us, again, it is going to be divisible by 2. So another 2 and so on. And you will be finally able to see that there are 6 2's. That means the prime factorization of 64 would be 2 power 6. So there is someone who have joined the meet. So I hope he is admitted. So yeah. So first you do this. Then you iterate the for loop from I equals 3. And then you go up to I less than or equal to n. And then I will do I plus plus. So there is one small optimization we can make over here. Instead of doing incrementing I, we obviously know that we have already removed all factors of 2. So obviously there are no multiple of 2 which is going to be a factor of the given number. So we can iterate through only odd numbers, and then if it is going to be a prime number, then we keep on dividing this number by I, and then we keep on printing I until that particular number is greater than 0. I hope you get this. Yes? Are you able to understand the approach? First, we are eliminating all the multiples of 2 in that number, and we are printing the same, the number of 2's. Then we are iterating from I equals 3 until I is less than or equal to n. And in each case, we increment I by plus equals 2, so that all the odd numbers are only traversed. So the total number of iterations can be halved, because we have already eliminated all multiples of 2, and then we are going to print the same. I hope that is clear. So what is the optimization we can make? So we can make an optimization based on the prime sieve we have already discussed earlier. So what can we do? So we will be maintaining an array which will be known as the smallest prime factor. So let us call it as SPF. So instead of in the prime C, what we did is we maintained an array called prime, which is going to be of the type Boolean. And then in for each index, we are just maintaining a Boolean value, whether the given number is going to be true or false. But here what we are going to do is we are going to maintain a number which is going to say the smallest prime factor for that particular number. So I hope you get it. It is just based on the prime sieve. So I hope you will be able to understand this directly when we see the code, and then let us have a dry run so that you understand the problem better. So this is the approach we are going to follow. So first we have, okay, this is going to be the naive approach that we discussed earlier. So here we have a vector called prime factors, and first we eliminate all multiples of 2, and then we push back that number of 2's into this prime factor, and then for I equals 3, I less than square root of n, we increment this by 2, so that we skip all the even numbers, and while n mod I is equal to 0, we push back I, so that I is definitely going to be factor of n, and we keep on dividing n by the given I. And we have also a statement over here. If n is going to be greater than 2, we finally push back n also. So what does this mean? If n is going to be greater than 2, obviously it is going to be a factor of itself. So I think I have missed something. You must be also including if the given I is going to be a prime or not. So we will be having an if case over here. If after generating the prime sieve, we can do if primes of I, so that only the prime numbers are calculated. So finally, we return this vector, which is going to contain all the prime factors and also the number of times it is going to occur in n. This is the approach number 1 we are going to follow. And we see that this is not very optimal, because here we are going to take approximately square root of n, and then here we are taking log n, because we have already seen that when we keep on dividing some number by its factor, it will decrease exponentially. So the total overall time complexity of this is going to be big O of square root of n multiplied by log n. So this is not obviously a good approach to be followed. So next possible approach is going to be based on the prime sieve that we discussed earlier. So here I'm maintaining a vector which is known as smallest prime factor. In the short form, we are going to have it as SPF. And first, this function is called, which is going to be known as generate all smallest prime factors. So first I'm going to resize this to n plus 1 as we did in the prime sieve. And for I equals 0, I less than or equal to n I plus plus. We saw in the prime sieve that initially all the numbers were going to be true. And here what we are doing, we are initializing this SPF such that initially we are assuming that the number is going to be the smallest prime factor of itself. So that we are initializing the smallest prime factor vector to be I initially. So then we run a for loop from I equals 2 and I will go up to square root of n. You will be able to see here I square is less than or equal to n, which is almost same as I less than or equal to square root of n. And I increment I. If the smallest prime factor of I is equal to I, what does this mean? This will mean that the particular number is going to be the prime number. Prime sieve, we have maintained it as to be a Boolean value that is true. Here, if we check that if the smallest prime factor of some number is going to be itself, then obviously it is going to be a prime number. So if that condition is satisfied, we run a for loop that starts from I square and go up until I less than or equal to n. And we mark the smallest prime factor of j to be I. I hope you get this. So for example, if you are going to have 2 and start this for loop, for all the multiples of 2, we mark the smallest prime factor of j. That is for 4, the smallest prime factor will be 2. For 6, again, the smallest prime factor will be 2, and so on. For all multiples of 2, which are less than or equal to n, we will mark the SPF of j to be true. And then when I equals 3, we will be marking for all multiples of 3 which aren't already marked by 2 to be 3, and so on. And we repeat this for all prime numbers until the square root of n. Then we call this function get factorization of n. What this function does is that it takes the prime factors vector, it takes the SPF vector, which is already global, and we are also creating another vector called prime factors, which is going to store all the prime factors of the given number n. And when n is not equal to 1, here in the whiteboard I have mentioned that a is going to be greater than 0. This is wrong. So a is not equal to 1 will be the case, because when we keep on dividing, finally the number will become 1. So until it becomes 1, we will be keep on iterating through our function. So we divide the particular number by the smallest prime factor of n. So now let's see how this works. For example, if we want the prime factors of 24, so the smallest prime factor of 24 would be 2 in our SPF. So we start dividing 24 by 2. First, we get our answer to be 24 divided by 2. 24 will now become 12. And then in the prime factors vector, we push back 2. Now, the smallest prime factor for 12 also is going to be 2 again. So we divide it by 2 and push back another 2. Now this will become 6. For 6 also, SPF of 6 is going to contain 2 again. So we divide this by 2 and then we push back a 2, which then it is going to be 3. And we see that 3 is already a prime number, so we push back. So prime factorization of 24 will be 2 power 3 into 3. I hope you get it. So this is how this algorithm works. Even this algorithm takes a time complexity of O of n into log of log n. As you know that it is just similar to the Sieve of Eratosthenes that we discussed earlier. This is also going to have exactly the same time complexity of Sieve of Eratosthenes. So I hope you get it. Are there any doubts in this topic, guys? So am I connected? Yeah. Can somebody please respond if there are any doubts, or if it is clear, just to mention that it is clear, or go with the thumbs up. Yeah, okay. Thank you, Achyutan. I hope it is clear for you. Okay. How to derive for time complexity? Yeah, as I said earlier, in each stage, Whenever you are going to design an algorithm of your own, you will be approximately able to guess the time complexity. Otherwise, there are theorems which are going to be followed, like Master's theorem, which would take a lot of time for you to prove the time complexity of the same. If you, for this predefined algorithms, we can just remember the time complexity. As I said, in each iteration, we are going to first iterate to n by 2 times, then n by 3 times, then n by 5 times, n by 7 times, and so on. All these are going to be prime numbers. So when we take n common out, we would have 1 by 2 plus 1 by 3, and this is a harmonic progression which would give you log of log n. This is all based on theorems and mathematical proofs. In computative programming, you will not be able to derive time complexity with this precision. That is not possible. That is possible only when you are interested in proofs and you have a lot of time. Amidst a contest, you cannot go sit, put a lot of theorems and proofs to derive the time complexity. In computative programming, all you can do is approximate the time complexity. So it is going to be something like O of log n. You can just by looking it, you can say that, okay, let me go to the code so that you understand better. Okay, if I looking at the code, you can see that this goes, so this will take n iterations, and you can see that this is going to be up to square root of n. And you are seeing that we are just growing, we are just going logarithmically, because at each stage we are just starting, we are going up to I square, sorry, I is going up to square root of n, and here we are starting from I square, and we are marking all these to be primes. So this would take again O of n time complexity in average. And here if you see, you keep on dividing the number by the smallest prime factor until that number becomes 1. So if you take some sample test case, if you take 100, the smallest prime factor will be 2, then 100 divided by 2, you will have 50, then 50 divided by 2, again 25. So you see that the number is decreasing exponentially. So at each iteration, we are trying to decrease the number in an exponential manner, so that the overall time complexity would be approximately log n. So if you are not able to decide the time complexity precisely, that it is going to be O of n into log of log n, you can approximate it something like O of n or O of n into log n. So this would be a good approximation. The best possible approximation will be O of n, because this is going to be very near to O of log into log n. Sorry, O of n into log of log n. So hope that answers your Sundar's question. So yeah, Sreesan has also given you some links. There are also some other links, as I said, we will be giving in the resource sheet. You can go have a look at these, where the proofs are given based on mathematical induction or theorems like Master's theorem. If you're a computer science student from Safar University, obviously you will have a course called DAA, where you will be studying these algorithms and you will be asked to prove them, their time complexities, etc., in the 4th semester or so. So if you're really excited, please be looking forward to the same. So yeah, that clears your question, right? Yeah, IT also has a course called DAA, but I hope you would be, if not in the 4th semester, you will be having in the 5th semester, if I'm not wrong. So yeah, IT and CSE would definitely have this course called, even CSBS guys are having this course. But yeah, they are having it a little later. So now the last topic for today that we would be covering is an introduction to. So I hope I am done with all the concepts to be covered. Yes, Reason, am I good to go with the last topic for
Yeah, I
today?
think you're good to go. You have covered every topic that was
Yeah,
planned for
okay.
today.
As per the agenda, I have covered all the topics we have that was planned for today. And so the last topic is an introduction. So let me zoom in a little bit. So this is going to be introduction to linear Diofuntin equation and chicken Mcnuggets theorem. This is a concept that most of you would be unaware of. Even I came to know only a few days back when I was solving a problem on CodeChef, which goes by the name COPR16G. The problem code is COPR16G. If you're really interested, you can go have a look at the same. So what does LDE mean? It is known as linear Diofuntin equation. So I hope I'm spelling the same right. So how does this equation look like? So it is an equation of the form ax plus by equal to c. So there are two variables over here, x and y. And how do we solve such problems? So here, in most of the linear Diophantine equation questions, what you need to find is whether a solution exists or not. If it exists, what the answer is going to be. So the equation will be of this form: ax plus by equal to c. This is known as a linear Diophantine equation. And according to the proofs given by mathematicians, the solution to this equation exists only when c equals the greatest common divisor of the coefficient of the both the variables, that is going to be a and b. So if you are given an equation like ax plus by equals 1, then you can be confidently saying that a solution exists to this equation only when the GCD of a comma b is going to be equal to 1. That is, only when a comma b are going to be coprime numbers. So this is going to help you in a lot of ways. After I cover chicken Mcnuggets theorem, you can go to codechef.com/problems/ this problem link. Otherwise, I will give it in the description chat box, so that after covering these concepts, you can go have a look at the question and try to solve it on your own. Even if you are not able to solve it, please do not get demotivated. It is the first time you are coming across such terms, and you can just have a look at the editorial. There are video editorials and also written editorials available for the same. You can have a look at that and then try to solve that problem. So what does chicken McNuggets theorem say? So what chicken Mcnuggets theorem says is the largest number n which cannot be represented in the form of ax plus by is going to be ab minus a minus b. And there is a condition. This is possible only when the GCD of a comma b equals 1. That is, a comma b must be coprime numbers. So what if they are not coprime? Let us take an example. If I am giving you a form of 2x plus 4y, and you must say the largest number that can be represented in this form, and you see that 2 is obviously a factor of 4, so all multiples of 4 would be definitely be of the form 2x plus 4y, if I am not wrong. So if you take 4, you will be able to represent it as 2 into 2 plus 4 into 0. Then you take 8, you will be able to represent as 2 into 0 plus 4 into 2, and so on. So there will be no end to this. So this is only possible when GCD of a comma b are 1, or else in other words, a comma b is going to be coprime numbers. In such cases, the largest number that can be represented in this form would be ab minus a minus b. Even I am not aware of these proofs, but if you're really interested, as I said earlier, the link to the proofs and more about chicken McNuggets theorem and LDE are given in the resource sheet, which you can have a look at later whenever you get your leisure time. So I hope with that we can conclude today's session. If there are any doubts and feedbacks, you can proceed with the same. You can unmute yourself and speak up. We are all friends. Otherwise, you can put it in the chat box. So if you guys do not want to solve the problem on your own and you want me to solve it live, that is also fine. But if you solve it on your own, it will be a practice so that you have learned something new today, and whenever you apply it, you will remember it for lifetime. That is why I have given this sum as an exercise. Yeah, Srisan, that is the problem. You're right. You got the link right. So, how was today's session? Is there anything where I messed up a little bit? Or else, if everything was clear, you can give your valuable feedbacks in the chat box. Yeah, thank you so much, Karthik. I am glad that my work has taught something new to you today. Yeah, thank you so much, Srini. Thank you, Sri Divya. So let me stop presenting. So is there anything, guys?
So I like to address certain issues. So we usually do this kind of a small chit chat after the every session ends. So the thing that I like to address this time is in our Discord server there are many suggestions asking us to conduct contest every week. The problem is conducting a contest every week is actually very hard for us because we are already in third year. So what we suggested was you guys can come and interact in the server and then try solving sums as a pair or as a group, right? So there are actually two or three people who are very interested in CP and then they want to solve a problem. So if you guys are also looking forward to solve problems, actually we cannot conduct contests every week. That's a problem here. So if you guys really want some peers, you can come into the server and then there are always two or three people as of now who are very interested to solve problems. So if you want peers, you can come and you can just talk there. So we cannot assure that everyone will be online at every time. So because competitive programming is not taught as a course in our college, right? So it's some kind of extension that we have in the college. And Courts of Sastra is a student-run community, meaning we don't have any capital investments. We don't have any donations from any other organization or students. So we do not have any this is student run community. So what we actually expect is we expect you people to come forward, right? So it is not just that we should be doing these sessions. Even as a part of this community you can come and contribute towards this. So for example, like we were preparing this resource sheet for the sessions that will be providing this resource sheet after the session ends, right? So if you can come forward and then you can contribute towards the resource sheet, so that will be easy for us too, right? So what it means to be a student run community means that every student can contribute, right? It's not just the core team must you should be working on anything at all. So before I go to the further issues, I'll be reading this message from Ashwath Govindarajan. I'm a fresher Anna who joined the WhatsApp group a little late. I've been following the recordings in a YouTube channel. It is useful for me to attend these lectures along myself or discourse of Sastra conduct a separate orientation for first years. Yeah, I think since first years we don't have any specific good connection with the first years as of now, because we have no mode for communication with them. The only mode for communication that we have currently is Discord server, WhatsApp, and then we also have Instagram, where we usually approach to some meme pages. The problem is since everything is in online as of now, we are not getting a proper response from the students. We cannot actually convey our message. Like even this session was postponed from 4 p.m. to 6 p.m. today, but we didn't get enough people because many didn't get the message, right? So this is a problem that we're actively facing. Yeah, this is a problem that we're actively facing. The one thing that I like to tell every time in every session is please come and talk in the Discord server. Only then we'll know like where you people are. So only then we'll get to know each other, right? So if you really want to practice, there is actually no issue. You can come just put it in the server. You'll also find many peers who are willing to do the same, right? So it is not just that only we should be. Could you please share the link for the Discord server? Yeah, I'll do that. Arjun, take care of the server. I'll be sharing a bit. I'll be sharing the Discord server link.
Yeah, okay, fine. So whenever competitive programming is concerned, it is like it is a sport. It is not a theory subject that you are learning from your university or college. It is like a sport. So it will be only interesting when you have peers and friends who are having a friendly competition with each other. So whenever you have doubts, we have voice channels or else text channels or a specific doubt channel too in our server. You can ask over there. So will be able to someone will be able to understand something new today, and then there will be also someone who will be able to solve the problem that you have or the bug in your code, anything it might be, and he will be able to help you. So that is how you build a community and you make friends with each other who are like-minded people, like who are you can get to know people who are already interested in competitive programming. You can make friends with them, and then you can attend contests together so that you will learn. Whenever you find people who are the same level of you and you discuss about competitive programming, and after each contest you discuss different approaches. So if I am going to be in a contest, if I'm going to solve some question in a Vanner, there can be Karthik Sriram who is solving it a different approach. So if we both discuss after the contest, we can get to know each other's approach, and next time we come across some similar problem, I would be having two different approaches to same have the same problem. So that is how you go about competitive programming. And another important thing I would like to say is, if you find these sessions useful, kindly promote these sessions with your friends the next time, so that there can be many of them who get benefited from these, and also our reach, the reach of our audience will increase. So we expected something around 50 people this time, but the maximum was around 20. But that is not a matter. I'm really happy that you all enjoyed this session and learned something new today. So yeah, that's it from my side. Is there anything you want to tell, Sreesan?
Yeah, so the core problem is we should actually stop at some point, and yeah, actually Umashankar is asking a question, so we'll cover after that. Just take the question. If you're using a function inside a loop, then time complexity will be that question.
Okay,
Arjun?
if we are using a function inside a loop, the time complexity will be O of n into time complexity of that function, since that function has also some time complexity. Right? Yeah, you're right. If it is going to be in a loop of, it is going to be linear loop, obviously it will depend on O of n into time complexity of n. Otherwise, if you are going to call that function inside a quadratic loop, that would definitely be O of n square into time complexity of that function. But you should also take care whether the given function depends upon the original input, or else the current iteration of your array. That is also another case. But for approximation, you can say it as O of n into time complexity of function. That is right. You got me right.
Yeah, so for example, in case if you want to find a minimum of two numbers, the complexity to find minimum of two numbers does not depend on the function loop or the input size itself, right? So that time you don't have to. And another common pitfall is when you're using containers like map and set, the time for insertion does also matter, because when you're using an array, if you want to insert a number inside an array, then that's basically O of n, right? So if you are using a map, the insertion depending on an ordered map or an unordered map, the time taken for you to insert an element in the map will also be considered, right? So these are some common pitfalls. You can also refer to that. You don't have to worry, because you learn everything while you go, right? So when you solve more problems, the core issue that I wanted to point out is, at some point you have to stop and start thinking that who is our competition, right? So we are not competing against each other, right? So on a whole we are competing to get better, right? So to thrive. So don't think that a student from our college is going to be a competition. It's going to be a friend of foe for us. Like, you have to compete against them, right? That's not the point of being in this community. So if you know something, you can teach that to some other person. Yeah, okay. If you know something, you can teach that to some other person so that they'll also learn, right? So in this manner, we can actually learn a lot. So if you actually see in the orientation session, I think we did cover about ICPC. ICPC is a very big competition. Most people do not have any interest in ICPC, but if you actually see that the Indians who appear for ICPC finals, like, is very low, right? So if we start competing against each other, like within us, then we won't be able to get further, right? So if you want to go better, if you want to be better, then you have to contribute to the community. You have to like work together so that we can do better, right? So anything at all, you can come to the Discord server, right? So if you're finding peers, if you want peers to solve who are if you want to if you're looking for someone who's in the same level as you, you can also find that in the Discord server. If there are around 470 people in the server, so it'll be good for you. I think we are good to end this session. If you have any more doubts, you can ask.
Yeah, I have something to say. Yeah, as the good example of what Sreesan said is like, if you had all researched about these topics, it would have taken hours or even days to understand these concepts. But since you attended this meet, it was like a discussion between two of us, and then you got all these important concepts covered in just 1.5 hours. So that is what the power of discussion. Whenever you teach someone, then your knowledge will not only improve, but you are just helping some other to become a good competitive programmer. So make friends. there are some misconceptions among freshers, like if there is someone who I am going to help in computer programming, and then what if he gets a better placement than mine? That is not the goal. Because if you help someone, not only they will grow, but you will also grow mentally. And also the companies which are coming to pick candidates from our college are not like I'm going to take only two candidates. So if there are top two, I will take only them, and all the other ones I'm going to leave. That is not the case. If some candidate is going to be deserving, he would take, he would definitely take them. So it is not the case that he is going to leave you and take your friend whom you thought. If you are going to be deserving candidate, he will take both of you. So please do not compete amongst your friends. Have a healthy competition and discussed after contest. And another issue we are facing is plagiarism. That is what most people from our college are practicing. Do not copy when the contest is running. After the contest has ended, you may discuss with your friends and try to understand different approaches. But during the contest, please do not discuss with anyone or copy code. That is no way going to help you. You might increase your rating today, and by that your resume might be promoted, but the interviewer will definitely able to get caught off. The interviewer will able to catch you definitely someday. So you are not going to improve your problem skills or something, you're just going to improve your resume. So please do not copy, guys. Maintain a healthy competition, discuss with your friends, know different approaches, do peer programming, be active in the Discord server so that we build a healthy community of like-minded competitive programmers, so that after 2 or 3 years, this would be a big club. The most of you who are attending today might also be the leaders of the club in future. So we must make this community big, and our aim is to make Sastra a better competitive programming campus. We must be able to see many Sastrites in the top rank lists of CodeChef and Codeforces. That is our
Sorry to
aim.
interrupt. Like the session is over. Can you stop the recording?
Yeah, okay, sorry, I have forgot to announce it. So yeah, that's it from my side, guys. So I think we are good to end this session today. Thank you so much. We have the part two of this session tomorrow, where Sreesan will be covering bit manipulation, modular arithmetic, and many other important concepts. So please do turn up. It is at 4 p.m. tomorrow, and it will go up to around 5:30 or 5:45. So if you find today's session helpful, please do ask your friends to attend tomorrow's session, because there are more important concepts than what I taught today, which are going to be modular arithmetic, bit manipulation. Bitwise manipulations are a very important concept. Every one contest out of two, you will get a question from bit manipulation, and that is where many people struggle. So please do turn up. Please promote tomorrow's event among your friends. Thank you. Have a nice day, guys. Bye bye. Good night.
Hello.